we need to solve another problem regarding the utilization and applicability of a steam table. So I have here a problem. So here, this is problem number 2, right? Oh, zoom out so that you can read properly, right? I'll give you 2 to 4 minutes to examine closely the problem and then take down the data and the given of this particular problem. Okay, if you want to solve now, I'll be able to read this one. Steam enters a diffuser steadily at 0.5 megapascal and 300 degrees Celsius and at a rate of 3.5 kilogram per second. Calculate the inlet calculate the inlet area of the diffuser when the steam passes at 122 meter per second. Oh my gosh. So in this problem, it doesn't specify the term saturation and it doesn't also specify the term superheated. Okay, you will be the one to identify. Okay, but it's very clear in our problem, steam is being mentioned. Okay, so you have to take note also if there is a steam mentioned, vapor, liquid and vapor phase, like that, saturation, superheated, like that. Okay, and then specific enthalpy, volume, entropy and internal energy, then you will feel that that kind of problem is really a thermodynamics problem involving the use of saturated steam table, okay, temperature based, saturated steam table, pressure based, and superheated, okay, steam, okay, like that. Okay, so it's either saturated steam or superheated steam. Okay, but superheated steam only used two, okay, temperature and pressure. So there's no such telling in the problem that it is only by temperature, by pressure. It should goes hand in hand together. So that is also your identification that it is a superheated steam. And another identification also, if you take note into account the temperature is very high, because from the word itself, so superheated, adjective, meaning you have to superheat that water or steam to achieve those properties. So if it is less than 100, how can you call that as a superheated? Okay, so you should also use your common sense when we can say it is superheated and when we can say if it is saturated. Because I also read a lot of comments also in my YouTube, something like that. Okay, then I answered one of the comments there, I think so, and then telling and saying, is this the way, if this is the kind of problem like this, we will use the superheated. Okay, like that. I answer him, you will feel that because the temperature given is above 100 degrees Celsius. Okay, because 100 degrees Celsius is a saturation temperature. So above that, okay, that is already superheated. And also, if there is a pair of pressure. Okay, normally in saturated steam problem, okay, with temperature based and pressure based, normally one temperature alone will do. Okay, in the problem, or one pressure alone will do. Okay, not two pressures, or not two pressures. Okay, because it's not dependent on pressure, something like that. It's temperature based if you will use the saturated steam at temperature based. Okay, there are also sometimes before phase 1, before phase 2, like that, so it's okay. Okay, but what I mean, you will use only one type of steam table, okay, if it is based on temperature on the problem, but it can never be stated there two, temperature and pressure, like that, because you will confuse which among them to use. Okay, so that means if it is a saturated steam table to use, there must be at least one temperature or two temperatures given in the problem, okay, but no pressure at all. Okay, like that. But the pressure, you can determine that in the table. It's in there. because there is an equivalent pressure there. What I mean in the problem, so given in the question or in the problem. So normally it will like this: steam enters a diffuser steadily at uh, example only 200 degrees Celsius. There's no pressure anymore mentioned. Or either steam enters steadily at 31 degrees Celsius, and then it enters in another, nozzle, something like that, at a temperature of like this. So it's also cover for the steam table. Okay, for example only, but the temperature is always less than or 100 degrees Celsius. Okay, so if it is above 100 degrees Celsius, you have now an idea that this is superheated. Aside from the fact that there is always temperature and pressure given in a superheated problem. Okay, because it will also be possible that sometimes also it will be given a less than 300 degrees Celsius, let's say, but it's still steam table to be used. Okay, but normally it doesn't to be like that because pressures are always be there also if you will give it a temperature in a problem, and then the temperature also will be there if you give it a pressure, vice versa, but never two. But this superheated two, temperature and pressure always given in the problem. You can identify aside from the word superheated or aside from the higher temperature, something like that. So you can now understand for that. Okay. So that will never be confused. Okay, so problems like this involve steam tables, okay, especially mentioning steam, saturation, superheated, again, blah, 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 so and so, liquid phase, before phase. You can feel, and there's specifics like this, specific enthalpy, like that, specific entropy, specific volume. So you can really guess that this is a thermodynamics problem involving steam table. Even though there's a given velocity here, it's given velocity and mass flow rate, right? But this is using steam table. Okay, something like that. So you can also apply here the fluid flow of momentum transfer because it's steadily man siya. So law of continuity is applied here. Do not forget also the law of momentum transfer or the law of continuity or the Bernoulli theorem, because the steam or any saturated steam or vapor will also pass in the pipeline. Okay, so that's why flow. Okay, so it could be liquid flow man siya. Liquid flow, or it could be gas flow. So liquid flow and compressible flow, okay, liquid man siya. But gas is compressible flow. But what I mean, if there's a pipeline like that, or any kind of, venturimeter, orifice meter, nozzle, diffuser, like that, or pipeline, okay, like that, an elbow of the pipeline connector, something like that, and then a tank. So usually in that kind of problems, it could be denied. There's also a mass flow rate, volumetric flow rate, like that, blah blah blah, so and so. So in that, it is very obvious that you can compute for the area, for the velocity, okay, for the diameter, for the density. Even though our topic here is using steam table, okay. Like that. Do not forget that also it will be mixed with a little bit of fluid dynamics, okay, fluid statics also, and momentum transfer in here. And it's also a mixture of physical chemistry, the entropy, okay, the second law of thermodynamics, the first law of thermodynamics. So this is really a combination, okay, of physical chemistry, thermodynamics, chemistry, physics, and also momentum transfer unit operation. Oh my gosh, really? Okay, plus later on also maybe there's also chemical reactions involved, so maybe it will be also mixed with kinetics, reaction kinetics, okay, how fast or slow the reaction really is inside the pipeline. Oh my goodness, it will be more complicated, right, if it will mix everything, and then you will determine what is the half-life, ganon. Oh my gosh, so it's just like, for example, I'm just imagining one type of problem and a lot will be there, okay. And then do not be panic, just really follow what's in your mind and connect all the theories, concepts, and principles and the formulas. So going back here, okay, now it is asking class the area. So since this is a diffuser, we will need to draw and illustrate the diffuser for clear understanding that the steam will go there and enters there, we need to picture out, because it will help us a lot to draw and to illustrate what's going on when the steam will enter to that particular, equipment or whatever, like that. This is also transport, okay? This is also a transport, momentum transfer. Really, okay? Gimix lang yun niya. Oh my gosh. So, a diffuser shows like this. If you should also familiar equipment also. Okay, since there's no equipment that much when we are still in college. So I think we will observe in our laboratory, especially in unit operations, there's a lot of equipment there, right? The distillation columns, like that, and whatever. You should also notice what are those types of equipment available in your laboratory. Okay, so most of them really have a circular opening. Okay, the pipeline circular opening. Okay, the diffuser circular opening, the hose circular opening, water hose, pressure hose, circular opening. So you have now an idea that you will apply the area which is pi r squared or pi d squared over 4. Okay, this is what we call as the cross-sectional area. Yes, the cross-sectional area, or shall we say circumferential area, if I'm not mistaken. Okay, so if we have the pi d squared over 4, and then we have the pi r squared, and we have our circumference 2 pi r. Okay, remember that circumference 2 pi r. Okay, then if we have also a volume of a sphere for 3 pi r cubed, the area of ganon. So study all the the shapes of the geometry, because it will be used also here. Oh my goodness, because you will be computing the volume of the sphere, the volume of the cylindrical tank, the perimeter of the rhombus, ganun siya, or what else, rectangular, container, whatever, chuba chuchu. Okay, like that. So it will help a lot if you memorize if you memorize the volume formula of those shapes, you also memorize the area. Okay, because it goes together along the way, because area is very useful in volumetric flow rate and mass flow rate in overall material balance, and also in energy balances. Okay, that's the focus and concentration of unit operations. You should know how to balance the energy that comes in and then the energy that comes out, and also the masses will comes in and the masses will come out. Okay, something like that. So, and most of the time, assuming that there will be no wastage or recovery, so that or losses or fraction losses due to wastage, so that we can really equate in a steady state flow to apply the continuity law of equation, especially the Bernoulli theorem. Here, the Bernoulli theorem or the continuity law can be applied in 1 point, 2 point, 3 points, or how many points is that? As long as there is an equilibrium established, okay, in a steady state flow. But in here, do not put headache on your mind. There's no other point. The steam is only entering in 1 point. Okay? Now we have to have a solution. Given, gaganon. I-illustrate muna. So this is the diffuser. Okay? Class, the diffuser is the reverse of nozzle. Okay? The diffuser, the liquid flow or the gas flow will start from a smaller area or diameter and then go to the higher area or bigger area or diameter. So meaning to say, the velocity will decrease, okay, in the outlet. And the inlet, your velocity is fast. And then in the outlet, your velocity will be slow because it's a higher area, because the relationship of area and velocity is inversely proportional with each other. The more you have a higher area or big area, your velocity will be lesser. Or it could be also the more you have a high diameter, your velocity will be lesser. And the reverse holds true. The fast the velocity if your diameter is very small. Okay? Like that. You should take note the relationship versus the theory before anything else. And then also the relationship of the pressure and the velocity. Okay? The pressure and the velocity, you will, if there is a high pressure, the velocity will be decreased. And now, if you want to apply that relationships in the, also in the force, in the area and the pressure, then you can have the pressure equals to force over area. What will happen to your pressure if your area is this? What will happen to your force if like this, and connect that also to the velocity? Then you can have a lot of quantities relationships so that your answer in the end, it is valid, reliable, acceptable, okay, and it is logical, because sometimes your answer is not really logical because there's a small diameter and then your velocity is very small in the outlet, so that means your solution is wrong. Okay, so that's the point there, that we should know the concepts, okay, the foundation of those quantities, okay, like that. It's possible also we can apply the pressure force over area here, and also the work, also possible, really. All possibilities will be here, okay. The work, the energy, as I told you, energy, Bernoulli's theorem, and the Stokes equation also, okay. The Stokes equation that involves differentiation and integration of energies. That is more complicated compared to Bernoulli. The Navier-Stokes equation and the Euler equation. Okay? In my part, when I was in college, I avoided that two methods of solving the momentum transfer, the fluid flow. I'd rather go with the Bernoulli because it's easy to understand. And it can produce the same answer man siya. Okay, the same answers but different methods or formulas to be used. That's my point. Okay? Maybe if I take the the integral and differential now, and I memorize the integration from 1 to 25, right, to 27, and then the differentiation from 1 to 2. Maybe I can do also that kind of equations, but I forgot something like that. Maybe I can remember only few, but I forgot most of it. Or, that's why I don't like, okay? I'm only, liking the algebraic expressions, combination with geometry, and a little bit of analytical chemistry, analytic geometry, okay? Right? Okay, going back to diffuser. This is diffuser. Oh my gosh. Laoy. Lagot ko. Diffuser. So, the steam will go here. And this is 0.1. And this is 0.2. Here. This is 0.1, diameter 1. 0.2, diameter 2. And then here, the steam will go out here. Since this is steady, it's mentioned also in the problem, it's steady, meaning laminar flow. Okay, it's not turbulent. So if it is steady, meaning applying the continuity law, or you can directly use the formula of the mass flow rate without equating to other points, like especially if there are other points have no given at all. Anyway, this will go also there. It's not our concern, man good siya. Our concern is to compute man good the inlet area. It's not the outlet area. If the problem will see also outlet area, then the question also will force to have given also in the outlet part. But it doesn't mention man talaga siya. Don't put headache on your mind. If there's no outlet in the two, then don't put given. Okay? Sometimes also, me also sometimes, okay, I need to, find out what are the given for 2. So because I want to apply the continuity, 2 is equals to 0.1 is equals to 0.2. Mass flow rate 1 equals to mass flow. Because we are used to that, okay, most of the times, right? In in the fluid flow or fluid dynamics, or even in chemistry, right? We need to 0.1 calculation, essentially calculation like this equal to 0.2, and assuming equilibrium, ganun. Okay, it doesn't have to be like that, okay? Like, you know the point? Okay. So, like that. So, pwede ra siya, enlit ra gyud siya. Okay? So, this is the diffuser. Okay, like it. Uy, naurot na dyan akong kuan. Akong pentel pen. Like this. Ganon. Ganon siya ha. So, it's gonna be mass flow rate, guys. What's the formula of mass flow rate? You're gonna think of mass flow rate and volumetric flow rate. Usually, what comes on your mind, it involves really how heavy, how light the liquid or gas will pass into the pipeline or whatever container. Okay, and at the same time, you will take note how fast and how slow the liquid and the gas will pass through that pipeline also, or container or whatever. Two comes in your mind. How heavy, how lighter the fluid and the gas will pass through the pipeline. So that means density. Okay? How fast, how slow the liquid and the gas will pass to the pipeline. Meaning to say, the velocity or the speed. But usually this is velocity because there is a magnitude and direction. Okay? It's not only the speed. Okay, when you talk about molecule transfer, especially the momentum, the mass, and the velocity, right? So it should be the magnitude and the direction should be considered. This is a vector quantity, not the scalar quantity, right? Okay, you get the point? So there must be a, a direction involved. Okay, like that. Because we need to account the final destination and the initial destination. So the displacement of the distance covered also. As the fluid and liquid will flow to the pipeline, we also note the distance covered for that particular fluid and liquid. So normally naman talaga siya, the length of the pipeline, the length of the tank, something like that will be our distance covered. Okay, but what if it will be a cut somewhere along the way, portion 1, portion 2, portion 3. If there are several compartments inside the tank, or there will be a lot of connections going to the right, going to the left, zigzag, going top and down. So, the distance, it's not a distance anymore. That's why I told you it's a vector quantity. It's the displacement. Okay? The displacement of the fluid flow, or the liquid flow, or the gas flow. Okay? Muna itong mga timan-an dyan siya. Okay? So, we have now the mass flow rate. So, okay. So, di na dyan maglibog mo na dyan na siya per me. Wow. Okay. So, mass flow rate. Mass flow rate is equals to the density, okay, the velocity, okay, the area. Hala. As you can notice pala, class, the mass flow rate is closely related to the Reynolds number. The only difference in the Reynolds number to determine how turbulent and laminar our flow of fluid, okay, is we have the viscosity in the denominator. Okay, right? So it's easy to detect. And also, what is being considered there is the length aside from the area, and the diameter is the what we are referring to as the length, as capital L. Okay? Ganun siya. Okay? Ganun siya talaga. Fairness. Ganun. Okay. Now, substitute values na ta, guys. So, mass flow rate, 3.5 kg per second. Density, we don't have the density, right? The density of the steam. But we have the velocity, 122 meter per second. Okay. And we don't have also the area. Oh my gosh! I need two quantities to solve, so technically we need one more equation to solve. If we have two variables to be asked, then it's also two equations to be used. Normally in mathematics, that's what I remembered, it should be directly proportional. If you are asked for three quantities, then you have also three formulas to be used. Okay, and then two formulas to be used, two equations used. Unless there's a lot of, like this, table to be used. You can find that in table, the graphs like that. It will be okay, but What I mean in normal circumstances that we don't refer to those tables, chuba chucho, or graphical, representation, then it would be like that. Okay? But since this is really thermodynamics, physical chemistry, a mixture of physics and chemistry, like that, we need to have tables, paragraphs to support our data here. Okay, there are two quantities that are missing. We need to solve the area. So area is equal to 3.5 kilogram per second. Density in which we don't know yet, and 122 meter per second. Okay, so this is our formula now. And we need to get this individually, the density of the steam as it goes to the diffuser. Okay, ganun siya. And then, we still have the area to find out, which is our main problem. We don't know yet this. If we have the density of the steam, then we can get the answer. How can we get the density of the steam? From the word itself, steam, meaning we use the steam table. Now, there are two types of steam table as what I discussed over and over again. Saturated steam and superheated steam. And now we have an identification I mentioned already a while ago. Okay, I don't have to repeat that one. So we will be using the superheated steam table because 300 degrees Celsius above 100 degrees Celsius. At the same time, pressure and temperature are given to this. Okay, it's super obvious. It's being superheated before it passes to the steam at the diffuser. Okay, so this is very hot. 100 degrees Celsius already hot. When you boil the water at 100 degrees Celsius, very hot. Right? How much more is 200 times 3? Okay, so just like that. Imagine how hot is that. Okay, so if you are complaining with too much temperature at 49, 59 because of high humidity in August, like that, or in summer, this is more higher. If our planet Earth would have 300 degrees Celsius, maybe all of us will die. If the temperature of the planet Earth in our surrounding like this will reach 300 degrees Celsius, maybe all of us will be burned. Okay? And what's the reason behind for that? Because the heat of the sun has its own regulation of the temperature. Even though how hot is that, it can regulate by its own heat amount that will be radiated to the surrounding. Okay, it will not directly transfer to the planet Earth. Okay, the heat transfer through radiation, still heat transfer. Okay, the third part, heat transfer through radiation, right? Heat transfer to convection, heat transfer to conduction, and heat transfer to radiation. So talking about radiant heat energy of the sun being transferred to the animals, to the plants, living organisms, that's heat transfer through radiation. So the energy that is being transferred there is the radiant heat of the sun, or radiant heat energy coming from the sun. Okay? And it will never be beyond 100, of course. What will happen if too much high? So just like this, so meaning superheated. So very clear in the problem, right? We don't have to put headache in our head like this. All we have to do is to troubleshoot the terminologies, the adjectives, like that. We should also, familiarize not only, fast in solving without thinking the phrasing of the problem. So I told you, passing certain examinations, if you are really good in English, is an advantage because you can really interpret terms by terms also. And you can analyze very well. Well, not really very well, you can understand good enough because you can understand how it is being phrased in the problem. So it will add an advantage compared to those not really that, you know what I mean. Okay, but usually, if you are good in mathematics, you are also good in interpreting English statements. Most of the time, directly proportional. But there are also times you're only good in mathematics, but sometimes you are not really, articulate with the terminology. Sometimes it will not also give you, better understanding. Okay? I think that is the reason also you can see very intelligent and then, very intelligent, summa cum laude, but at the end of the day, they will never also become a top-notcher. Okay, like that. And The whole people already expected you to become like that because you are the summa cum laude, you're the number one, and you know you are a winner of something like that. But then in the the others who top is not really that magna cum laude, summa cum laude, but become the top notcher. You see the difference? Maybe there's something lacking for that magna cum laude or summa cum laude or whatever. Maybe he's not really that good in English or only good in mathematical ability. Maybe the theory is not very well, ganon, whatever. Because there's no reason, because he's very intelligent already, or there's a lot of intelligent battling for that particular examination all over all over the world. All over the nationwide, something like that. Sorry. Okay, because it happens also things like that. The whole people will expect you, especially for example 10 outstanding students of the Philippines, like that, and then summa cum laude, okay, and then winners of engineering mathematics quiz ball, mathematician of the year, ganon, and then highest grades like this. I mean, when taking the board examination, did not even in the top 10. So I don't know, okay, because it's already expected, right? Maybe there's also a lot of super intelligent in that batch, something like that, right? But for me, in my own analysis, it could be theory concepts, and principles, really. Okay, maybe the problem solvings are perfect. They solve everything perfect, but maybe the theories are not really that perfect. The trivial questions, okay, because most of the theories, concepts are trivial sometimes in science, right? Sometimes you cannot find in the book, okay? You cannot find in the book. You will just only read that in the newspapers, in the encyclopedia, in the magazines, or you hear that in the news. There's something like that, okay? Because the books are formulated a long time ago, very old. So there's no latest scientific discovery at this modern times, like that, and then it will come out in the examination also. You get my point? Because these topics are always keep repeating. Okay, 3,000 years ago, we're still using this kind of formula from Isaac Newton, Bernoulli, Anton Lavoisier, Entroichen, ganon, Nernst-Simons postulate, Haber process, Arrhenius theory, Legitimate principle, ganon, Chuba-Chucho, John Dalton, Ernest Rutherford, G.G. Thomson, like that, okay, James Chadwick, like that. Dami, Jules Priestley, okay, Henry Cavendish, okay, Alexander Fleming, Albert Einstein, something like Alexander Newberg, okay. Alexander Newberg? Alexander Newberg is the father of modern biochemistry. And also George Davis is the father of chemical engineering. Okay, George Davis. Oh my gosh, really? So you should research, read, like that, okay? So, and now, I can get the density by finding that in the, since this is more on chemical engineering thermodynamics, I will use the Paris Chemical Engineers Handbook for this. Okay, now class, diba, we have interpolation. You remember the interpolation? Oh my gosh. Then if, for example, if this is at 300 degrees Celsius and there's no 300 degrees Celsius there in the superheated, superheated steam, okay, at 0.5 megapascal at 300 degrees Celsius, it's not found there, then you have to interpolate. Okay, so at 300 degrees Celsius, and then you have the X as your density to be find out, and then it is from the initial and the final closer to 300, let's say 350 and then 400. The 300 will be in between 350 and the 400, something like that. So your ratio will be like this: 300 minus 250 over 400 minus 250. Just like a slope in algebra. If you will try to graph that one, it's gonna be like that. Okay? So if we let X as the center, okay, you're gonna be like this: X minus X1 is equals to X2 minus X1. So you can project that also by graphing. You can understand because that is a slope. Okay, something like that. Okay, M, small letter M. The principle is just like that. Okay, and then in the other side also, the values of the density. Then you don't know the density, so you put that in the middle as X also. Okay, then X minus the first value of density at 350 degrees Celsius, and then we have also the density at 400 degrees Celsius, and then like that, minus X minus blah 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 blah, and you can formulate an equation, linear equation to solve for the value of X. Okay, that's your density now at 300 degrees Celsius. That's interpolation. I don't have to show this because it will take time. Okay, I expect you know that you know how to interpolate. Charot! Okay? This is not ratio and proportion because ratio and proportion is another thing. Okay? Like that. This is interpolation. But now guys, if for example, we have also double interpolation and triple interpolation. Okay? So if it will not be satisfied to the single interpolation, then when we go to that double interpolations, as what I could remember, okay, interpolation by single interpolation is the commonly used by all engineering students, but in rare cases we also do the double interpolation, in which majority or most of the students cannot understand this too much, including me. Charot! Okay. Really, for example, if we have a superheated steam at 300 degrees Celsius to 5 megapascal, but there's no 5 megapascal here also in the superheated table. So what you do now, you need to get first the value of density at 300 degrees Celsius, and then you also consider now the pressure. Okay, the pressure. So what is close to the pressure there? For example, 0.1 to 0.1 megapascal to 1 megapascal. So the 0.5 megapascal also is in the center in the pressure, because we don't have that in the table like that, 0.5 megapascal. So we should interpolate also the pressure. Okay? Ganon-ganon siya. And then, after that, you interpolate that with the density. Okay? Sa 200 degrees Celsius, 150, nakakuha naman kaya, you get already, right? That interpolation of the density at 300 degrees Celsius, ganon, you get that already. So you need to find now the density at 0.5 megapascal. Okay? Like that. And you have the density at 1 megapascal, and you have also the density at 0.1 megapascal, and you have density also the 1 megapascal through interpolation. Okay? Then you can solve for the density through 0.5 megapascal by having a second interpolation in terms of the density that you obtain in the temperature first. Okay? Something like that. So double interpolation. Okay? Be careful also. This is not single interpolation. After that, you will get the final density, which is this. So you can have the answer like that. I don't have to go through because, I don't have Paris Chemical Engineer's Handbook, and then I don't have also, I'm tired of finding in the, superheated table, and I have the table here, but up to 0.15, and this is, 0.5. Okay, how can I interpolate? I need 0.1 megapascal and 1 megapascal to be in the center, which is 0.5. But my copy is only from 0.115, so I cannot find the answer. So that's why I told you, just go to the tables and have your own interpolation, and bingo, you can solve for that density. Okay, and tell me later what is the area. Okay? Because I don't know the area also unless I will know the density. Or unless I memorize how it is being solved. Okay? Because I don't solve on the spot. I don't solve in preparation prior to my vlogging. Okay? So, meaning I solve directly. Okay? Without referring to the original solution. Okay? Because it looks like not difficult, magod siya. Okay? Okay? Like that. I can feel also if it is very difficult, it's not difficult too much. That's why I told you before, don't focus on too much difficulty. problems or highly complex problems. It will not go out so many in the examination. Maybe out of 100, they will only give 5 difficult or 4 like this, but not all will be difficult. Okay, for the problem solving, then you will the theories have also concepts and theories. So many like this, so that it should be even, so that your scores will be pulling it up. If you are very poor in problem solving, then it could be pulled it up because you have high in theories, concepts, and principles questions, right? If you feel you are not really good in mathematical ability in the problem solving, then build adequate memorization and the theories, concepts, so that it can raise your scores at least. Okay, get the point? And don't tell me you cannot solve also other problem solvings. There you can still solve, right? Say out of 10, 6. So more or less you will pass. That's why I told you, develop more the theories, concepts, and principles. Okay, how much more you are good in problem solving, and then you develop also the theories and concepts and principles, there's a chance really to become a top-notcher. Sure. Really, if you are very good and intelligent how to solve problems like that, and your IQ is very high, and then you are also loaded with memorization, full memorization of the processes, like this, the formulas and everything, theories, trivial questions, more or less or most likely you will become a top-notcher. Okay, but if you are not really good in problem solving, don't expect to become a top-notcher, but it is expected you will pass. Okay, because as I told you, you are not really that bad in problem solving, manggod. Okay, unless bugo jud kay kag problem solving, imposible masag kayo. It's very also impossible that you are good in theory and memorization, but you are poor and not good in problem solving. Maybe you are not good, but not poor. Okay, so it will pull up your scores really. Okay, it's impossible also that bugo kay maayo kay kag theory, bugo kay kag problem, di man na siya mahitabo. Okay, if you are really good in theories and concepts, there's a chance that you are still good in problem solving or hina ka, but then maka-answer gyapon kag mga problems solving in the questions. Okay, so that's why mo pass cube ka dapat. Okay, and what is the problem really? Some are taking for granted the theories and concepts and principles, magud siya. Mo siya mahitabo. They taking for granted the theories, questions, the concepts, the principles, the definitions, like this. Okay? So the relationships, to kung gipangyaw-yaw sa mga theories, wa naman gusto nila sa uban. Okay, nagsiglan sila ganang sago sa mga katulad yung mga formulas, sige sa practice mga isud kay nga mag problem solving, 100 taga adlaw, 100 taga adlaw daghang kay sulbon. Nya ila lang isang tabi ang mga theories. Muna mo take sila murag siguro mo pasar sa kasagaran nila sa siguro, pero naadyo mo fail kay importante makayo ang theories and concepts and principles. Good balance dapat 50-50. Okay. Okay, but in my part I am more on the theories and principles rather than problem solving in my case. I don't know with the others also, maybe they are more on the problem solving and fair in the theories and concepts. That's why they passed also. In my part, I am more on the theories and concepts and principles, but not too much in the problem solving. Okay, and then I passed. But the worst situation there, if you are both not good in 2 areas, okay, so the possibility you will fail, right? And then, but if you have higher theories and principles, and then if you come out in the board examination is only small problem solving, let's say only 10 out of 80. Okay, so you have still 70 items. Okay, so dagan jud kay score, puno jud nimo. Charot. Okay. Guys, this is subjective. This is subjective. I am only relating my experience, but not the experience of others. This is only my experience in the actual chemical engineering board examination. Okay? Thank you so much for watching this short live stream. I hope you like this video, and you can comment down below in the comment section, and then you can click the notification bell for some newest updates every single eternal voice, my CHE diary, and pure sciences, occupational safety and health. Next week I'm gonna having my vlogging and short live streaming regarding one of the topics of occupational safety and health this time. Okay? But wait. I still have to organize my presentation. Okay? I don't want to be disorganized. You know what's real? You know what's the story? If I'll be able to vlog and live stream occupational safety and health, I want to be organized. Okay? In my discussion. But when I vlog this related to sciences, chemical engineering, mathematics, I don't really want to be organized. I don't want to prepare too much. I just read, like this, memorize a little bit with the formulas, okay, loaded in my mind, something like that. Okay, but I don't really practice, okay, problem solving and memorize how it is being solved. Because for me, it is not a challenge. Okay, to present a vlogging and live stream, you already solve in your own, and then you just present to your viewer. There's no challenge at all. That's why it took me a long time, right? If you will feel it, and then you will feel boring because sometimes, oh my God, it's so very long. Pwede naman siyang i-diretso because that is on the spot. Okay, I have so many things in my mind. Okay, when I solve, so it's not shortcut. It's not direct. Because if I solve that first, it's very direct. I can easily get the answer. Okay? Scripted ba? Okay? Because usual vloggers in YouTube are scripted. Mangguna sila. Okay? Scripted and prepared so that it can save their time. And then, maybe siguro, so that they will not be ashamed for the impression and the impact after their vlogging and their live stream. But for me, it doesn't matter at all. I don't mind, okay? Because in the first place, nobody is perfect in this world. Okay? That's my mentality kasi eh. So the more I became wrong, the more I become challenged, and the more interesting is the discussion. Okay? You get the point? Because it leads us to think if we get wrong. So, if we get wrong, we really learn a lot. And we learn our lessons out of our errors. So that would be more, more challenging compared to those, you prepared, you memorize the solution like that, and then perfect. Oh, ganon. Grabe ka, perfect. Step 1, step 2, step 3, step 4. Formatted talaga. Okay, but in my case, I don't like that. Okay? Okay, the theories, it could be because I have stuck knowledge in theories, and sometimes also I have to memorize new terminologies also that I read, okay, like that. But for the solving of the problems, I don't really prepare. Okay? Charot ay. Lagi, mojud na. Thank you so much. Bye-bye. God bless everybody. Thank you so much for watching. Laoy.